Hi students, I am Sumalata. In today's class, I am going to teach you about mole concept. At what time we are going to use this mole concept, we will learn in this class. And one more thing, just watch complete video, then only you will get complete idea and you will get complete information what I am saying in this class. And one more thing, I just want to explain one problem that was mentioned in the comment box in my previous video, that is the atomic mass unit. One request from my side, subscribe my learners chemistry channel and like these videos and share these videos to other students. That makes me more energy to make some more videos regarding this chemistry subject. Now coming to our topic, students, mole concept. Actually students, if you take any chemical reaction, if you want to tell quantitative representation of any chemical reaction, how can you tell? To that one you have two ways. One is the how many number of particles participated and how many number of particles will formed in that chemical reaction. Another one is how much mass is involved in and how much mass will formed in that chemical reaction. These are the two ways to tell quantitative representation of a chemical reaction. To understand this one, you just take an example. Hydrogen reacting with oxygen, students, they will form water molecule. Okay, here two molecules of hydrogen reacting with one molecule of oxygen, they will form two molecules of water. This is the one way of representation. The another way is 4 units of or 4 atomic mass units of hydrogen reacting with 32 units of oxygen and they will form 36 units of water, students. Okay, here among these two ways, which one is the convenient way to tell the quantitative representation? The first one is the convenient way to tell the quantitative representation of a chemical reaction. At this time, the concept mole was introduced by the scientist William Ostwald. See, 1 mole of anything. See, what do you mean by mole? Mole is nothing but it's a massive heap of atoms or particles. It's a large number. See, 1 mole of anything or any substance, nothing but maybe rice, maybe fruits or vegetables, or 1 mole atoms or 1 mole molecules or compounds or particles, anything which is having the number of particles are 6.022 into 10 power 23 particles are present in that 1 mole substance, students. Okay, this number also known as the Avogadro's constant or Avogadro's number, which is indicated with the letter N naught, capital N naught. Okay, this value coming from the experimental data only. Up to this extent, okay, it is the this number indicates how many particles are present in a substance, 1 mole substance. If you want to tell massive representation for 1 mole substance, nothing but what is the weight of 1 mole of any substance? How can you tell? To tell the massive representation of 1 mole of any substance, you have to take gram atomic mass or gram molecular mass. See, where we are getting these gram atomic mass or gram molecular mass, these values are coming from the relative atomic mass or relative molecular mass. See, how can you correlate these two values? Nothing but gram atomic mass and relative atomic mass, gram molecular mass and relative molecular mass. How can you correlate? Just take an example, students. Suppose you want to tell 1 mole oxygen atoms weight, how much you want to know. To that one, you can take first of all relative atomic mass of 1 oxygen atom is equal to 16 AMU, students. After that, I want to know the 1 mole oxygen atoms weight. I want to know. How can you calculate? To this one, you just do cross multiplication. Then you will get 16 AMU into 1 mole oxygen atoms. This is equal to the 1 oxygen atoms weight or 1 mole oxygen atoms weight, students. Okay, so you can substitute the values. What is the AMU value? 1.67 into 10 power minus 24 grams. And what is the 1 mole value? 1 mole value is the, we already know, 6.022 into 10 power 23, students. So that here you just simplify these values, 10 power minus 24 and 10 power 23. By cancelling this one, you will, the remainder is 1 by 10, students. Okay, and if you simplify 1.67 and 6.022 in 22, you will get only 10, and the remaining is 16 into 10 into 1 by 10 into gram also is the remainder. So 10 cancel, remaining value is the 16 grams. That is nothing but 1 mole of oxygen atom having 16 grams, students. Okay. At the same time, this 1 mole of oxygen having oxygen atoms having 6.022 into 10 power 23 atoms. Nothing but just simple one. 1 mole of anything having its molar mass, okay, and 1 mole of anything having Avogadro's number of particles. You just remember these two things. Okay, see, this is the molar mass of oxygen, molar mass, capital M. Okay, molar mass of oxygen, and this is the Avogadro's number of particles present in the 1 mole of oxygen. If you want to tell, this is the gram atomic mass of oxygen, students, then you can take one example for gram molecular mass. How can you tell? I'm going to take water. One water molecule having relative atomic mass is the 18 AMU. Then same this procedure you have to apply here also. I am not writing. Okay. Then 1 mole water having weight is the 18 grams. This is the molar mass. This 1 mole of water having Avogadro's number of particles. I think you may understand now. 1 mole of water having 18 grams weight and 1 mole of water is equal to the Avogadro's number of particles. This is the weight representation. This is the number of particles representation. Okay. Then coming to how can you calculate mole value? See, to that one you can take some formulas. Mole indicated with the letter small n, students. See, small n. Okay, if you want to calculate the mole number with respect to the mass, then you can take m by small m by capital M. Here capital M is the molar mass, small m is the given weight. If you want to calculate with respect to the number of particles, you can take n is equal to n by n naught. If you want to calculate with respect to the volume, then V by 22.4 liters, ORR 22.4 decimeter cube. You can take, you have to memorize these formulas, then you can go to calculation of number of moles or weight or liters, anything you can do. Okay, you just take some examples here, students. What is the mole number present in 12 grams of oxygen gas? 12 grams of oxygen gas having how many number of moles? How many number of moles? To this one, here he gave weight, given weight, m is equal to 12 grams. So you can take first formula, students. N is equal to m by m. Given weight is the 12 grams and molar mass of oxygen gas he represented. So that you should not take atomic mass, you have to take molecular mass of oxygen, because oxygen gas exists in the form of molecular state only. So here 32 grams. Okay, so it is 3 by 8. That will gives you 3.375 moles are present in the 12 grams of oxygen gas. Okay, this is one. Take one more example, that is 0.2 moles of oxygen atoms having how much weight? How much weight? So to this one also you can take the first formula, students, that is n is equal to small m by capital M. You have the value small n and m also. So m is equal to n into m. So n value is the 0.2 into m is the molar mass. Here he just mentioned atom, so that you can take gram atomic mass, not gram molecular mass. So the value is 3.2 grams of oxygen present in the 0.2 moles of oxygen atoms. Okay, you just try to take one more example also. If 0.1 moles of carbon having how many number of particles? To this one you can take this formula, n is equal to n by n naught, students. So n is equal to n into n naught. N is the given number of particles. So is equal to n value, how much we have in the formula, given data 0.1 into n naught is the 6.022 into 10 power 23. Okay, so the answer is 0.22 into 6.022 into 10 power 23, students. This is the answer for this question. And one more thing I just want to tell, that question was mentioned in the comment box. My previous lecture, that is the atomic mass unit. I just want to explain that question. See, in a substance, 98% of C12 and 2% of C14 isotopes are there, students. Then in 12 grams of substance, what is the number of C14 atoms? In 12 grams of substance, number of C14 atoms present. We have to calculate this value. To this type of problem, students, first of all you have to take average atomic mass for these two isotopes, C12 and C14. Here two isotopes are there, so that average atomic mass for these two isotopes is the atomic mass of that isotope and relative abundance. What is the relative abundance? 2%. So 2 by 100 plus what is the another isotope? 12 into 98 by 100 students. If you simplify this one, you will get the value 12.04 grams. By seeing this, what you have concluded, if 100 grams of a substance having 2 grams of C14 students, then 12.04 grams of substance having how much weight of C14 isotopes. To this one also, here you can do cross multiplication. You will get 2 into 12.04 divided by 100 students. Then you will get the value is equal to 0.2408 grams. Okay, this is the weight of C14 isotopes present in the 12 grams of substance. Then you have to calculate the number of particles present in this amount. Okay, so 14 grams of C14 you can take. 14 grams of C14 having Avogadro's number of particles, nothing but 6.022 into 10 power 23 particles students. Then 0.2408 of C14 having how many number of particles? That is the thing he is asking. Here also cross multiplication. 6.022 into 10 power 23 into 0.2408 grams divided by 14 grams students. Then you will get the value 1.032 into 10 power 22 number of particles are present in this particular amount of substance. This is the explanation for this question students. I think you are all understand about this topic. If you have any doubts, just mention in the comment box.